So for elastic collisions in 2 dimensions, I want you to go ahead and jot down this problem, okay? We're not going to start doing any math until everyone's got written down what they need to. Kind of start wrapping your head about what's happening in this problem. I'm going to kind of talk through it as you're writing it down, so hopefully you can kind of just picture what I'm saying here. We're going to, this gray object right here, it has a velocity to the right, okay, of 2.4 meters per second, and it has a mass of 0.5 kilograms, okay? It hits this white object, which sits at rest, okay? So think of this in terms of like pool, okay? When you're playing pool, this object would be hitting one sitting at rest. After the collision, this gray object moves at an angle of 30 degrees with a speed of 1.8 meters per second. The white object, we don't know its velocity post-collision, okay? So that's going to be our overall goal here, is to find the speed and the angle at which this white object is moving after the collision. As we're talking about elastic collisions, I want you to think about the equation that we're going to be trying to use here, okay? If we think back to our elastic collision problems, we use the equation m1 v1 plus m2 v2 equals m1 v1 prime plus m2 v2 prime. Okay, does everyone remember that equation? What does the prime mean right here? It means post-collision, yes, exactly, after these two have collided. What about the subscripts 1 and 2?
That's your different objects.
Exactly, the different objects, okay? So I want to be clear about what these subscripts mean. As we go into breaking these things into components, we're going to add some subscripts to them. We're going to have to add x's and y's. So we need to make sure that we understand that those subscripts have a purpose and they tell us certain things about those objects. All right, so we've got to be careful in knowing what those subscripts and these prime and everything that we're adding to those variables mean. We can start plugging things into our equations. We've got to get things out of an angle. Okay, we don't like working with things at an angle. So we need to break this down into components. Okay, we're going to break down this vector into components. So if this is v sub 1 prime, somebody tell me in words what v sub 1 prime means.
Velocity of the first object after collision.
Perfect. Velocity of the first object after the collision. Okay, so this gray object, with this, which is our number 1, that's its speed after the collision. So if I'm going to name this component of that vector triangle, what would its variable be called?
V sub 1 x.
Say that one more time, Margaret.
V sub 1 x prime.
Yes, perfect. V sub 1 x prime. Okay? I know that seems like a lot. I know that seems like those subscripts are hard to remember, but each of those things tell us something. Okay? The v means it's the velocity. The 1 means it's the first object. X means it's the x or the horizontal component. And the prime means that it's after collision. Very good. Okay? Now if I want to name this side of the triangle, what would I call that?
V sub 1 y.
Exactly. V sub 1 y prime. Very good. Okay, now we have to solve for those two. We can't deal with things at an angle. So we need to solve for v sub 1 x prime and v sub 1 y prime before we can really get going on our problem. Okay, because we're going to have to solve for momentums separately, horizontal one and vertical one. So let's solve for v sub 1 x prime first. Is this v sub 1 x prime adjacent or opposite of our 30-degree angle? It's adjacent, which means we use which trig function? We're going to use cosine. So we'll take 1.8, which is our hypotenuse, times cosine of 30. Please make sure that your calculator is in degrees, not radians.
1.6.
Okay, good. I think we get 1.56 or something. So we get 1.56 here. Is this going in the positive x direction?
Yes.
Yes, so that means it gets to stay positive. Now let's solve for v sub 1 y prime, which is going to be the speed of our first object in the y direction after collision. Okay, so to solve for that, we'll take 1.8 times sine of 30 because it's opposite of our 30-degree angle, and we get about 0.9. Is that going in the positive y direction?
Yep.
Yes, so it gets to stay positive. Okay. It was to the right, so I'm just going to put a little arrow there so I know that it only has a horizontal component, right? This velocity right here, has no vertical component. Are we in agree? Like, we agree with that? It's only moving horizontally, so no vertical component. The mass of our second object is 0.3. And what's its initial velocity? 0. Okay, it's not moving at all, so it doesn't have any horizontal or any vertical components to it. Okay, we solved for v sub 1 x prime and v sub 1 y prime, so I'm going to move those over here to our list. All right, and we want to solve for v sub 2 prime, right? That's our overall goal. In order to get there, okay, if we're trying to solve for v sub 2 prime, which we know is at an angle, in order to get there, we have to solve for v sub 2 x prime and v sub 2 y prime.
Then do just add them.
After that, we'll build them together, build a new triangle, and then we'll use our Pythagorean theorem. Okay, so let's just take it slow for a second, all right? Are we clear that these are the components we need to solve for? In order to solve for v sub 2 prime, which we know is at an angle, we have to solve for the components first. Okay, are we on the same page? So in order to do this, we've got to solve for momentum. We'll use our elastic collision equation, but we have to do it by x and by y. Okay, so let's start with x. So we'll solve for momentum in the x direction first. Okay, these problems, it's extremely important that you stay very organized. Make sure your subscripts are in there. Make sure you're labeling vertical or horizontal, x or y, whatever you want to call it. Okay, I like to draw like a little line so I know that these equations are only going to be for the x. This is not some secret math symbol that you don't know. This is just me trying to be organized. Okay?
What is this that we're about to do?
We're doing momentum, okay, for in the x direction. This is the m1 times v1 plus m2 times v2. Okay, I'll go ahead and write it up here. So m1 times v1 plus m2 v2 equals m1 v1 prime plus m2 v2 prime. Okay, but this is all going to be in only the x direction. So let's go ahead and plug things in here. The mass of our first object is 0.5. Its initial velocity, is it in the x direction?
Yeah.
Yes, and it's in the positive x direction, so we get to plug in positive 2.4. The mass of our second object is 0.3, and its initial velocity in the x direction is 0. So let's just get a plug in at 0. All right, so now post-collision, our masses don't change, but we know v sub 1 prime in the x direction is
1.56.
yes, this is exactly what we solved for. So when we broke down that velocity triangle, we solved for the velocity of the first object after the collision in the x direction. So we know it's 1.56. And we're going to take, I'm kind of running out of room here, our mass of our second object, and we're going to solve for v sub 2 x prime. Okay, and that goes up right in here in this little spot, but I ran out of room. Okay. I'm going to move this down and make it a little bigger so we can see. Okay. All right, so v sub 2 x prime is what we should be solving for. So let's go ahead and get that solved. What's this term give us right here? I don't have my calculator with me. 0.7 something? 0.78? Okay.
7. Oh, it's 0.5.
Okay.
Yeah.
All right. If we need to get this term by itself, what do we do to the 0.78? We subtract it over. Good. Okay, which gives us what right here? Point.
Wait.
Just right here.
Oh, my bad.
0.42? Okay. All right, so then to solve for v sub 2 x prime, we'll divide by our 0.3, which means we get, what, Grace?
1.4.
1.4 meters per second. Okay, and since it comes out positive, we know it's going in which direction? To the right. All right, since that's what we chose to be the positive direction the first time. So we've got one of our components there. v sub 2 x prime we now know equals 1.4, and it's to the right. Okay. So now we need to solve for our y direction, our momentum in the y direction. Can I clear this part off? Or actually, I have room down here. I'll just do it down the bottom. Okay. So we'll solve for our momentum in the y direction, or py. We'll use this same equation, okay, except we're doing it in the y direction now. So I'm not going to rewrite that. Our mass doesn't change. Does our initial velocity of our first object have any y component? No, which means we get to put a 0 right there. Okay. Okay. Our second object has no initial velocity at all, so that gets to stay. What about, what variable should go right here?
0. Wait.
This is our first object after collision. Exactly. V sub 1 y prime. Okay, because that's our first object, because that's what our 0.5 tells us. First object in the y direction after the collision, which should be a 0.9. Okay, and then our second object is 0.3. We're going to solve for v sub 2 y prime. So the whole left side of our equation will equal 0. We want to subtract over the 0.45 to get it by itself, get the v2 y prime by itself. And we'll divide by our 0.3, which means v sub 2 y prime is going to equal. What's the negative tell us here? Yeah, it's going down. Good, exactly, because we solved for a y. It's a negative, so that means it's going in the downward direction. So I'm going to plug that into our list of things up here. Negative 1.5, or we know it's going in the downward direction. Okay, now we're almost there. We have the components now of our second object's final velocity. So once we have our components, we need to add these vectors tail to tip, use our Pythagorean theorem, and our second tangent to solve for that. So we know it's our x vector is going to the right at 1.4, and we know our y vector goes down 1.5 meters per second. We need to solve then for our resultant vector, okay, which would then be v sub 2 prime. We also need this angle right here, theta. Okay, so let's do a quick review if we need to about how to solve for this. Solve for v sub 2 prime, we use what?
Second, or this.
To solve for the side of the triangle, we use Pythagorean theorem. So we'll take square root of 1.4 squared plus 1.5 squared. And that should give us, I think, 2.1. All right, so that's half of our answer. To solve for theta,
Do second tangent, opposite over adjacent.
exactly. To solve for theta, we're going to take tangent -1, or second tangent of our opposite side. From this theta angle, we're going to take our opposite, which is 1.5, over our adjacent, which is 1.4, and we get
46.97.
47 degrees. Okay, so if we're at 47 degrees for this theta, it's 47 degrees what of what?
North of east? No, we're south of east.
South of, yeah.
South of east. We went east and then south, so it's 47 degrees south of east. So go ahead and take a look at what this says. Kind of wrap your mind about what's happening. There's one object that's moving 12 meters per second to the right. It breaks up into two separate objects. Okay, so this is kind of like a reverse inelastic equation. But we're going to start with one object. They break apart. The second object goes south at 15 meters per second. Or the first object goes south. The second object is what we're trying to find. Okay, so we're trying to find the speed and direction of our second object as it flies through the air. All right, so are we ready for me to clear this off so it has some room to work?
I don't know what the question is, though.
We're solving for the velocity of this second object.
Oh, okay.
Okay, which it's okay, yeah. Sorry, it's supposed to be like showing. Okay, there we go. We're solving for the velocity of this object. So we know its mass, we don't know its velocity, and we're going to find its speed and the angle. Okay. All right. So are we good to clear this off? Okay. So what we know from this problem is that our object, okay, the mass of both of those together as one single object is 7 kilograms. Okay.